Right, so I always get questioned how much 3D printing costs in terms of energy. So I bought this energy meter here off eBay. It's pretty cheap, like 10 quid. And you should be able to monitor everything that you plug in your power supplies, including the costs. So you can put the costs that your energy is currently, and it will give you an estimation based on the amount of time you run. So as you can see, you have here kilowatt hour, there's a timer here at the top, voltage meter, and frequency from the power grid, current, power, high and low, and we're gonna set up here the cost per kilowatt hour. You should be able to pick that from your bills. Currently here in UK, the prices are quite high. I can't remember from the top of my head how much I pay. So I'm gonna set this up for 30 pence per kilowatt hour. I definitely pay less than that, but this should give me an overestimation on how much a print would cost in terms of energy. So pretty straightforward. You set up the price and you should be good to go. In terms of installation, I think it's even easier. You just get your main power outlet, plug that in before plugging the main appliance. So I'm running an extension cord here, but there is just one printer connected to it, and that should be good to start. Right, so for the first test, we are going to power the machine up. I'm using a Ender 3 V2, and the results that I'm publishing here will vary according to your machine. This machine has a 300 watts power supply. Apologies for the noise, there's probably something stuck in my fan here. Just need to wiggle that a little bit and you will. So I was saying, it will depend on the power of your machine. So at idle, and even with my LED being powered by the main power supply, as you can see, we barely hit 15 watts of consumption, so pretty much negligible. We can do the calculations later on to see how much that would cost in a day. So you're going to notice that the peak power consumption comes usually when you are heating stuff, mainly because you need to warm up the hot end and the bed. So I'm warming up PLA now at 60 degrees for the bed and 200 degrees Celsius for the hot end. If we monitor the power consumption now, it's probably going to reach the maximum limit of my power supply, and that's probably just going to be there for some time, so until my temperature gets to the set point that I've made. I'm gonna speed the video up a little bit here, and it should be bringing to a, let's say, steady state level once the temperatures are reached. So we are approaching now the hot end, and now the bed is up to temperature. So I left the printer warm for a couple of minutes, and as you can see, the power consumption dropped to around 100 watts level. Now that I'm printing, essentially, we have to add the power consumption from the stapler motors, you know, the board making calculations and stuff like that. So as you can see, for PLA at these temperatures, we are around 100 watts right now. So what I'm gonna do, I'll leave it printing. It's not gonna be a long print, I think like an hour and a half, 2 hours print. And we will see what the meter is gonna tell the cost will be based on that 30 pence per kilowatt hour that I've input earlier. So come back in a couple of hours. Right, so at the end of my print, you can see there in the top, the timer took about 2 hours to complete the print. And at the bottom, the total cost that I've spent doing this print. So printing PLA for 2 hours gave me a cost of around 5 pence based on that 30 pence that I've inputted in my meter at the beginning of the video. So roughly 2.5 3 pence per hour printing PLA on my settings. Now we're gonna do the same thing for PETG, and you probably noticed that during the warm-up it's going to be exactly the same, around 320 watts of consumption. The temperatures that I have for PETG is 230 in the hot end, 70 in the bed. It will just take longer, so I'm gonna speed the video up so you guys don't get bored, and at the end we just have a look in the what is the steady state consumption, and we can do some calculations and how much would it cost to print an hour of PETG and another hour on ABS. Notice how the power consumption drops quite significantly once the nozzle is up to temperature, and drops even further now with the bed reaching the set point. So I'll just launch here a PETG print. As you can see, my machine is starting. So we'll do some calculations based on the number. We get back at the end of the video. Right, so we're gonna do that third time here. Apologies, I've started the preheating before starting recording. So as you can see, my ABS settings will take 230 degrees Celsius in the hot end and 100 degrees Celsius in the bed. So this will probably take much longer, but still using the same 320 approximately watts to heat up the elements. Now, my PLA took about 2 minutes to warm up, my PETG roughly 5 minutes. The ABS takes about 10, and notice again the power consumption had dropped a bit because the nozzle is already up to temperature, so the main power consumer now is the bed, and it will take just a bit longer. I'm gonna take some calculations on how much the heating part would cost for all these 3 elements based on the times that I've seen here, but that's probably not gonna be the bulk of the cost within a printing hour. So let's say if you're printing for 10 hours, 5 minutes, 10 minutes warm up won't be very significant, although the peak of the power consumption will happen in that phase. I'm launching now the ABS print so we can see the average power consumption during the functioning of the machine, and we'll do next the calculations for all these 3 materials. Let's jump into some calculations here. So 1 kilowatt hour, which is usually the unit you will see in your bill, means you're using 1000 watts for an hour. 320 watts is equivalent of 0.32 kilowatts. Now, if you use that 320 watts for an hour, you will have the power consumption of 0.32 kilowatt hour. Now, let's talk about the idle phase. A lot of people are concerned about leaving their machine on without printing, thinking that will be a huge power consumption. We checked at the beginning of the video that only consumes about 15 watts. If you run that for an hour, you end up using 0.015 kilowatt hour. If you leave your printer idling for 24 hours, you will end up using 0.36 kilowatt hour. If you multiply that by our current rate, the 30 pence per kilowatt hour, that will only cost you about 10p to run or to idle the whole day. Now, during warm-up, let's use the worst case scenario that we established here, warming up taking 0.32 kilowatts and taking about 10 minutes to warm up in the case that we saw for ABS. 10 minutes means 0.16 hour. So 0.32 kilowatts times 0.16 will give you 0.05 kilowatt hour. If you multiply that by our current rate, 30 pence per kilowatt hour, the total cost for this warm-up will be just over 1p. Jumping to PLA, we established that we use 100 watts in average for printing PLA.
So that's 0.1 kilowatts times an hour equals 0.1 kilowatt hour. 0.1 kilowatt hour times our current rate of 30 pence per kilowatt hour will give you the 3 pence per hour like we checked on the meter. If you print that for 24 hours, it will cost you 72 pence. For PETG, we established we use 150 watts in average for printing. That's 1.5 the amount that we use for PLA. So for simplicity, I'm just gonna multiply the cost of PLA by 1.5. So that will give me around 5 pence per hour, and a full day of 24 hours will be around just over £1. ABS consumes 200 watts, which is the double of PLA. So again, for simplicity, we just take the cost of PLA, multiply that by 2, and that will give you roughly 6 pence per hour. A full day of printing ABS, that's twice the cost of PLA, and that will give you 1.44 pounds. I've summarized in these charts the cost for printing all the 3 materials that we discussed and the idle phase. In the blue color you will see the cost per hour, and in green color what will cost you per day. Bear in mind this is based on my current rates for energy and also my temperature settings for each of those materials. Thank you very much for watching. See you next time.